Hello, this is the first video for chapters 2 and 4 on organizing and summarizing data. We're going to cover some selected sections from chapter 2 and some selected sections from chapter 4 that all have to do with organizing and summarizing data. So here are the sections that we'll cover. Section 2.1 on organizing qualitative data. Section 2.2 on organizing quantitative data. Section 4.4 about contingency tables. Section 4.1 about scatter diagrams and correlation. Finally, Section 2.4 on graphical misrepresentations of data. So first we'll talk about Section 2.1, which is about organizing qualitative data. The objectives for this section are 1. Organize qualitative data in tables, 2. Construct bar graphs, and 3. Construct pie charts. So objective 1 is to organize qualitative data in tables. When we talk about a table in statistics, we're usually talking about what we call a frequency distribution. So a frequency distribution lists each category of data and the number of occurrences, in other words the frequency, for each category of data. Reasons for constructing frequency distributions. They help us summarize large data sets. They help us gain some insight into the nature of the data. And they give us a basis for constructing important graphs. Here's an example of constructing a frequency distribution. So the data below represent the color of M&Ms in a bag of plain M&Ms. We're going to construct a frequency distribution for the color of the plain M&Ms. In other words, someone dumped out a bag of plain M&Ms and went through one by one and wrote down the colors of each of the M&Ms in the bag. So here's our data again. To construct our frequency distribution, we're basically just going to make a table that lists all the categories for the data, in this case the different colors. And then we're just going to go through this list of data and put a tally mark in each category as we go through the list. And when we're done with that, we'll count up the frequencies for each color. In other words, how many M&Ms of that color were in the bag. So if we went through and did our tallies, that's what we would end up with. And now we can count the frequencies for each one. Brown would have 12, yellow would have 10, and so on. Red would have 9, orange 6, blue 3, and green 5. So our frequency distribution is actually the list of colors and the frequencies for each one. Now another type of table we can create is a relative frequency distribution. And the relative frequency, instead of being the count of how many values are in each category, it's the proportion of values within each category. So to find the relative frequency for a specific category, we take the frequency for that category and divide it by the sum of all the frequencies. In other words, the sum of all the frequencies means the total number of observations that were in our data set. Sometimes we want to represent relative frequencies in percentage form. So in this case, the formula is the same. So we take the category frequency and divide by the total number of observations. And then to get the percentage form, we just multiply that by 100%. So a relative frequency distribution lists each category of data and then gives the relative or the percentage frequency instead of the count. Here's an example of creating a relative frequency distribution. So we're going to construct a relative frequency distribution of the color of plain M&Ms using the frequency distribution that we already had from the prior example. Here was the information that we got from tallying up the M&Ms of each color. Now, to find our relative frequencies, we need the total of all the frequencies. In this case, we need to know the total number of M&Ms that were in the bag. So that's our first step. If we add up all these frequencies, we get 45. So there were 45 M&Ms in the bag. Now, to get our relative frequencies, we just take each category frequency and divide it by our total, which is 45. So our first one is going to be 12 divided by 45, which gives us approximately 0.2667. For our next one, we would divide 10 by 45, then divide 9 by 45, 6 by 45, divide 3 by 45, and divide 5 by 45 to get the rest of our relative frequencies. Once you have all these calculated, you can check your answer by adding up all of the relative frequencies. And it should come out to be 1 or something very close to it. Sometimes with rounding error you might come out with a 0.99 or a 1.01, but it should be very close to 1. Now, to get our percentage frequencies, we're just going to take the values that we got for our relative frequencies and multiply each one by 100%. And how much the values are rounded depends a lot on what you're going to do with them. In this example, I rounded the percentages to the nearest tenth of a percent. Again, you can check your answers here by adding up your percentage frequencies, and they should add up to 100% or something very close to it. The second objective is to construct bar graphs. So a bar graph is just a graph that has each category of data represented and labeled, usually on the horizontal axis, and the frequencies or the relative frequencies are on the other axis. Sometimes you see sideways bar graphs, but in this course, most of the time, you'll see your categories with the labels on the horizontal axis and the frequencies being on the vertical axis. So we draw rectangles of equal width for each category. The height of each rectangle represents the category's frequency or its relative frequency. And we have a slightly different type of graph called a Pareto chart. It's just a bar graph where we draw the bars in decreasing order of frequency. In other words, the category with the highest frequency is going to be on the left, and it's going to decrease down to the category with the lowest frequency, which will be on the right end of the graph. Here's an example. We're going to use our M&M data to construct 3 different graphs: a frequency bar graph, a relative frequency bar graph, and a Pareto chart. So here's the information that we have. We have the categories, which are the colors. We have the frequencies, the relative frequencies, and the percentage frequencies. First, to do our frequency bar graph, all we need is the colors and the frequencies. So here's our frequency bar graph. Notice we just have a bar or rectangle for each color. They're labeled down on the horizontal axis, and then the heights of each bar tells us the frequency for that category. So looking at this graph, we could see that there must have been 5 green M&Ms because the height of this rectangle is 5. Now for our relative frequency bar graph, here are our colors and our relative frequencies. And here's our graph. The only real difference between this and our frequency bar graph is what happens on the vertical axis. Here we have relative frequencies, so we have decimal values instead of the actual frequencies or counts for the categories. So for our red category, we can see that the height of this bar goes up to about 0.2. Now finally we'll look at a Pareto chart. And for a Pareto chart you can use frequencies, relative frequencies, or percentage frequencies. I just did this one with the percentage frequencies because we had already used the other two. So here we have our colors and our percentage frequencies. And our Pareto chart, again, lists the highest frequency category first on the left and then goes in decreasing order. So the lowest frequency category will be the furthest one on the right. So this goes from brown, which had the highest frequency, down to blue, which had the lowest frequency. Now one place that we can use relative frequency distributions or relative frequency graphs is if we're comparing two data sets, especially if the two data sets have different total frequencies. So here's a case. We have data for two different years, 1990 and 2006, representing the marital status of U.S. residents 18 years of age or older. And the reason that we would use relative frequencies here is that if we get our total number of U.S. residents for 1990 and for 2006, we're going to have different totals. You can even see by looking at these two columns with just the frequencies that it's a little hard to compare them. It looks like, just looking at this, that the widowed stayed about the same from 1990 to 2006, but if you consider that our totals are different, that's not really the case. So in order to draw a relative frequency bar graph of this data, we need our relative frequencies. So first, before we can draw the bar graph, we need to get the relative frequency distributions for both of these 2 years. So again, the first thing we need in order to calculate relative frequencies is the total of all the frequencies. So the total for 1990 is 181.9, and the total for 2006 is 219.7. So again, you can see these two totals are quite a bit different. Now for 1990, we're going to divide each category frequency by the total for that year, which was 181.9. So here we're taking 40.4 divided by 181.9 times 100%, because we're going to do this as a percentage bar graph. And that gives us 22.2% if we round it to the nearest tenth of a percent. The rest of our percentage values for 1990 are married is 61.9, widowed is 7.6, and divorced is 8.3. Now for 2006, instead of dividing by 181.9, we have to divide by the total for this year, which was 219.7. So our relative frequency for never married in percentage form is 25.2%. And here are the rest of our percentages. And again, looking at the relative frequencies gives us a different picture of our two distributions. Remember, if we looked at the regular frequencies, it looked like widowed had increased slightly from 1990 to 2006, which it did in actual count, but percentage, it actually decreased from 7.6% down to 6.3%. The same thing is true of the married category, because in actual numbers, the frequency increased from 112.6 million to 127.7 million, but the percentage of the total decreased from 61.9% down to 58.1%. So now we're ready to draw our side-by-side bar graph. So here's the data that we need. We have just the percentages for 1990 and 2006 for our different categories. And here's our bar graph. And this really shows what is happening between 1990 and 2006. Again, this is talking about the percentage of the total. So the never married, you can see the percentage increased. For married, the percentage decreased. For widowed, it decreased. And for divorced, it increased. Objective 3 in this section is to construct pie charts. And you've probably seen pie charts before. A pie chart is just a circle that's divided into sectors or slices. Each sector represents a different category of the data. And the area of each sector or slice is proportional to the frequency of the category. Here's an example of constructing a pie chart. We're going back to our data about marital status for U.S. residents. And for pie charts, we need relative frequencies, because we need to know the proportions to figure out how big to make our different slices. So we're just doing this for 2006, so here are the relative frequencies for 2006. And then our pie chart gives the percentages for each category. Now sometimes you'll see pie charts with the counts included, which is fine, but you do have to have the relative frequencies in order to actually figure out the size for each slice. And here are our data labels over here. Now one thing that's interesting in this pie chart is if you compare the relative frequencies over here, which were rounded to the nearest tenth of a percent, these frequencies are rounded to the nearest percent. And notice that all of these got rounded down except for this one, which got rounded up to 11%. Now the reason for that is that whoever constructed this pie chart wanted the total of these percentages to come out to be 100%. Now with rounding error, if this had been rounded down as it really should be to 10%, then these percentages would have only added up to 99%. But the reason they rounded that one up is that it was the one that had the highest value in the tenths place of any of these. So it's the one that made sense to round up instead of rounding down.